In example 4, we have a blood bank that catalogs the types of blood, including whether it's Rh positive or Rh negative, given by donors during the last 5 days. The number of donors who gave each blood type is recorded in this table below. So we've got the blood types going across the columns, and the Rh factors are the rows. Find the probability that a donor selected at random has type O or type A blood. So as soon as I see the word or, this is where I need to worry about if these events are mutually exclusive or not. So in order to do that, I have to think about if my event A is being type O and event B is being type A, is it possible for someone to be both of those? And the answer is no. If you're type O, you can't be type A blood type. We all have just one single blood type. So therefore, these events are mutually exclusive. So the probability of either A or B happening will be the probability of A plus the probability of B. And again, this A and B are just generic names for the events. I'm not referring to the blood types here. So event A is having a type O blood type. So I'm going to go right here to this chart. How many type O people donated? I want the grand total of people, so that would be 184 people were type O. Out of how many donors total, you can find that number here in the total in total, which was 409. So that's the probability of being type O. Now I'm going to do the same thing, but for the probability of being type A. So I'm going to go to the type A portion of the chart. I'm going to look at how many people total were type A donors, which is 164. And that's again out of 409. And again, there's no need to do any subtraction here because there were no people who would have been counted as both. So I'm going to go ahead and add my numerators. 184 plus 164 is going to give me a total of 348 out of 409. And that will be equivalent to the decimal 0.851. Find the probability that a donor selected at random has type B blood or is Rh negative. So my event A will be having type B blood, which again, I guess is a little bit confusing. But as long as you have things labeled, you should be okay. And event B is going to be being Rh negative. Are there people who were type B and Rh negative? Yes, there were. There's 8 of them. So these are not mutually exclusive events. If they're not mutually exclusive, we're going to end up double counting these 8 individuals. So we're going to need to do that subtraction at the end. So the probability of being type B. In order to figure out the probability of type B, I want to find the total number of type B donors, which at the very bottom here is 45. So that's 45 out of 409. The probability of being Rh negative is my second event. I'm going to look along the negative Rh factor row, and I'm going to look for the total number of donors, and that was 65. And you can literally see in how I've highlighted things in this chart that I've counted these 8 people twice. They're in the total for Rh negative and they're in the total for type B. So therefore, the probability of being both type B and Rh negative is 8. So I need to subtract those 8 folks off because I counted them twice. So add 45 and 65 and then subtract 8, and you'll have 102 out of 409 donors, or in other words, approximately the decimal 0.251. 0.249. So about 1/4 is the probability that a donor selected at random will be type B or Rh negative or both. I've included in the notes just a screen capture of this summary that was in the textbook. So I just want you to know that it's there and it kind of summarizes everything that we've talked about so far with probability. So the last skill you really need is now to start to integrate all these different probability techniques together in order to answer a question. In example 5, we're told to use the figure to find the probability that a randomly selected draft pick is not a running back or a wide receiver. Now there's two key words in here that are giving us some direction in this problem. The first is the word not, and the second is the word or. Or is always indicating that we're looking at using the addition rule. And if we're looking at using the addition rule, we need to be concerned about whether or not our events are mutually exclusive. The word not signifies the complement of a probability. So we usually save the complement for the very end. So I'm going to begin by leaving that word off to the side and just defining my events as the probability of selecting a running back and letting event B be selecting a wide receiver. Are these events mutually exclusive? The answer is yes. If you're drafted as a running back, you weren't also drafted as a wide receiver. And you need to know a little bit about sports, but these are mutually exclusive events. So in order to find the probability that I do pick a running back or a wide receiver, I just need to find those individual probabilities and add them up. I don't need to do any subtracting because there's no double counting going on. And so I would get probability of A. Well, I can see right here in the chart that there are 23 running backs out of a total of 253 players. And event B was the wide receivers, which are right here. There are 31 of those out of 253. Add your numerators, you get 54. Keep the same denominator, 253. And don't bother going to get a decimal for that yet, because now we do the complement of that. So to find the complement of A or B, I'm always going to do 1 minus the probability that I found for A or B. So 1 minus 54 out of 253. You can use a calculator, but here's just a little quick recap. If I want to do the subtraction, I need to rewrite 1 as a fraction with the same denominator. If I want my denominator to be 253, my numerator would have to be 253 also, because this will reduce to 1. So I can rewrite 1 in this format so that I can now easily perform the subtraction by hand. I can do 253, take away 54, and that's going to leave behind 199 out of 253 of the players, giving me a probability of approximately 0.787. So going back to the chart then, we've just found out that 199 of the 253 players are not wide receivers or running backs.